want to do it?
Yes.
To a point.
Some, yes. Maybe
You
no.
got me. Give me a little suggestion.
So let's do it.
I
I would, but let's make sure you know how.
Yeah.
So all the sides are all ones. Both sides are ones. And then every other spot comes from adding the two numbers above it. So like this one here, the two numbers above it are both ones, so 1 plus 1 is 2. So this spot here, there's a 1 and a 2 above it, so you add those and you get 2 and a 1 above this spot. You add those, you get this spot, you got a 3 and a 1 above it, 4. Is that what I'm stepping in? I was actually curious. Do you get what I'm saying? Okay. Keep going. You don't have to, like, if you're at the point where you need to get your calculator out, just stop. I just want you to do it enough to, like, kind of practice what you're doing. And then I want to talk about what, like, all what the numbers mean. And so I get. And then you're going to be like counting over in each row, but the first number, like all these ones, are like your 0th column. They don't really count. Because if I said find the 4th row, you'd have to look at that whole, like this one, otherwise everything would be the first row. So that like kind of doesn't count when we're working with stuff, so it's called the 0th column. This one here is the first column, second column, third column, and so on. I think that'll make more sense when I start explaining what like, the numbers mean. I hope. How many of you guys have never seen this? Like people have seen it? Some. Advanced algebra maybe? Or like
Yeah.
binomial expansion?
I didn't know I did that one.
Okay, so let's say I just start looking at like a number in there, and we're going to talk about what it means. I'm going to choose this 6. We're going to go off to the side and like talk about that 6. So that 6, you can notate it. I want you to know how to notate it, how to say it, how to find it, and what it means. So to notate it, it would be 4. You put a parentheses and you put 4 on the top and 2 on the bottom. It's like a fraction, but you don't put the fraction on. What that means is 4 4 books up in the front of the room, and I said randomly come up and pick 2 of them, how many different ways could that happen? Well, there's my 4 books. You could choose the first book and the second book. You could choose the first and the third, the first and the fourth, the second and the third, the second and the fourth, or the third and the fourth. So how many ways did I just talk about? 6. So that's what that is. So this is number of ways to select 2 items from 4. So this, let me just talk about this row. This would be 4 choose 0, which is kind of weird to think about. Like if I said there's 4 books, how many different ways could you choose 0 of them? Like, there's only one way, you just don't choose anything. But that kind of like trips people up. This would be 4 choose 1. So it's the, you go 0, 1, 2, 3, 4. So there's 4 books. How many different ways could you choose 1 book? 4, right? You could choose the first one, the second one, the third one. This is what we just did. This would be choosing 3 books. So how many different ways can I choose 3 books? And this would be choosing 4. So if I said there's 4 books, choose 4 books, how many different ways can you do that? It's just one way, right? There's only one possibility. You just take all. Right, so let's say like the first row is like the 0 if you're choosing 0 books. So you don't really
Like when
ignore is a strong word, but kind of.
When you see the 4, you find the row. Or if it was 5,
When I see the 4, I ignore that part. I go to that row. Is that what you're asking?
Oh, I see. Oh, I see.
So yeah, let's start with that. Let's say I said 6, 3. 6 choose 3. Can you tell me which number that is? So 6th row means I'm here. And then this is the 0th, the 1st, the 2nd, and the 3rd. So that'd be 20. So the first one, this 1 always is like choosing 0. So I got I got 6. There's 6 people in the class. I'm gonna randomly like punch 3 of them in the face. This would be how many ways I could punch 0 of them in the face. I just don't punch anybody. That's one way. 1 person, 2 person. Okay, so this is 6 choose 3. And that would be number of ways to select 3 items from 6. That was 20. Alright, let's try it kind of backwards. So that 21. Don't say it out loud, like let everyone try it, but could you write out the thing in the parentheses? Could you tell me what choose what, and then what it means? So we're in this row. You can't say it's the first row because then everything would be the first row. So it's the 7th row. That's the 7th. This would be 0, 1, 2, 3, 4, 5. So that is 7. Choose 5. And that's the number of ways to select 5 things from 7. Doesn't have to be selecting too. Like, a baseball player is going to get 5 hits in his next 7 at bats, his or her next 7 at bats. How many different orders could that happen? It could be the first 5, it could be the middle 5, it could be the first, second. Like, there's all these different ways. if you're taking a test, you're going to get 5 questions right out of 7. Well, you might get the first, second, fourth, and 7th. You know, like there's different ways that all those things can happen. Does that help understand how to read the chart? So if I said to you, what is 9 choose 2? Don't say it out loud. What is 9? Okay, not say it out loud. What is 9 choose 2? 36. So that'd be 9th row, 0, 1, and 2. If I said, what is that? Like, what choose what? Don't say it out loud yet. And that'd be what choose what? 3 choose 1. Okay, good. Alright, let's look to the problems here. So I did that first one for you. Then I kind of regretted it later because the woman used like different notation than I did. So she used, let's just write at the top. So N is the number of trials. P is the probability of success. And then she used 1 minus P. I just use Q. Because like throwing another set of parentheses in there just seems to make it like more confusing for people. But you can use either one you want. Q is the same thing as 1 minus P. So if P is the probability of success, and Q is 1 minus that, then what is Q representing? Probability of failures. And then like I use K, she used X, it doesn't matter. X is the number that we're looking for, the number of successes that we are looking for. And then actually go back to the Pascal's triangle because I forgot to show you how to find the calculator. Does anybody need me to stay on this page so you can see that stuff? Okay, so in your calculator, let's say I wanted to find this 6 choose 3, which we know is 20 by looking at the table. But your calculator does it too, so get out your fancy TI-84. And you can do either. Like on the test, I don't care if you look it up in the triangle. Is there a triangle in the notes? So I can just write Pascal's triangle on the board with the test or something. I don't really think you'll use it at that point, but you might. You have like 5 blank sheets in there, so you could just write it in there. I could just give you a sheet to get. I really don't, by that point, I don't think you'll use it, but it's possible. So that 6 choose 3 is what I'm looking for. So the way that looks in the calculator is 6 NCR3 is what that looks like. So this is combinations. So you're looking for this button, basically. So you're gonna hit the 6. Last hour someone said like slow down. They're dead serious. Slow down, where's the 6? We all got the 6? Okay. So then hit math, and then go over to probability. And it's the 3rd one down there. We're not gonna use anything else in that list right now. So like don't worry about getting confused with the things. So I just said like right arrow or you can go left, whatever. I said left arrow, flip back. And then hit NCR, and then hit 3, and it'll say 20. So your calculator does this as well. So let's say I said there's 15 people in here, I'm going to randomly choose 4 of you. How many different ways can that happen? Well, that's too big, we don't have that in the triangle, so you got to use your calculator now. So do it in your calculator. 15 people, I'm going to choose 4. 15 choose 4, yeah. Not very big. It's easier to talk to a new one. I don't even know why. Like, I shouldn't have done it anyway. Alright, so if I'm reading number 2, I think it's very helpful to just write on the side all of it, like N, P, Q, and X. So I'm going to go on the side and say, N is the number of trials. Well, there's 5 multiple choice questions. So N is 5. P is the probability of success. Well, I'm assuming I'm just guessing. And it's A, B, C, D. So I'm just guessing what's my probability of getting that correct. 0.25? Is that what you said?
My bad. Sorry, it's not a true false.
A, B, C, D. Yeah, yeah. Yeah, I was just making sure. No. So the probability is 0.25. It's 1 out of 4, right? Q is the probability of failure. So what's the probability you don't get it right? It's 0.75. And then X is the number of successes that we're looking for. So I'm saying what's the probability that we get 3 correct? So X is 3. So your general formula is N choose X times P to the X power, and then Q to the 1 minus X power. It's times, yeah. So in our problem here, N is 5, X is 3, so it's 5 choose 3. And there's 2 ways I can find out what 5 choose 3 is. What are those 2 ways? Pascal's triangle and the covenant, right? So you can do either one of those. P is the probability of success, which is 0.25. And we want to get 3 correct. We want to succeed 3 times. So that's your power. And then Q is the probability of failure, which is 0.75. And we're saying we're going to fail twice. If we get 3 right, that means we got 2 wrong. So notice there's a couple like easy ways to check yourself here. What should these 2 numbers that I just underlined always add up to? Should always add up to 1, because that's like success plus failure. These 2 numbers should always add up to that. Because this is the total number of trials, this is successes, and this is failures. So if you add up failures and successes, you should get like the total number of trials.
Like that exponent on the Q, it's like 1 minus 3. Would that make it a negative?
But it's N minus X. My fault.
Oh, okay.
It's N minus. Yeah, yeah. Thank you. So then that like that kind of maybe we notice that. But you add those 2 up, X plus N minus X, you get N, right? Like that's what I was trying to say.
Okay.
Thank you. Thank you. So then you gotta figure this out. So you can do it in your calculator, you can look up 5 choose 3 in the table and then do it. Let's all like figure that out and see what we get. So like I'm just going 5 at NCR 3, get my calculator, getting 10, and then multiplying my calculator. So I never actually really use the table or the triangle. But some people do, and I want you to know where things were coming from. Don't worry about it. So I got 0.088. Agree? So that's the probability if I'm randomly guessing I'm going to get 3 questions right on it. So that has to do with like, I don't know which 3 questions. So this accounts for like all the different possibilities, and then this is the probability of getting them right. I want 3 right. This is the probability of getting them wrong, and I want 2. Questions on that one anywhere? Where did you get this from? Why did you put this here? Okay. Try the next one. Again, I think it's super helpful to go over here and just kind of write down N, P, Q, and X. No one's going to make you, but I think it's helpful. you're like a work ahead person, we're gonna skip 4 and 5 for today. We're gonna come back to them tomorrow. So for this one, I got 0.2646. If you're not getting that, let me know so I can like see what you're doing in your calculator. Garbage. You don't want to like get up. Get up. Making sure you can see it. All right, we getting what we're supposed to do? Okay. Questions I can answer at this point? Alright, skip 4 and 5. We're gonna come back to those tomorrow. So I'll be honest, this is one of those like I'm showing you kind of the long pain in the ass way to do it. And tomorrow I'll be like, oh, you just press these 2 buttons and you're good. Yeah. So I have to cheat through that to notice them.
Yeah.
So you gotta understand both though. Like the AP test will ask you about the process, not just the calculated function. And so will I. So try 6. When you do the probability for this one, let's just make sure we're all on the same page. What's the probability that I get a 1 or a 2? 2/6 or 1/3. Put one of those 2 things. Don't put 0.33. Because if you round it and then you start doing it to powers, it just rounds it more. And you get like further and further away from the true answer. Yeah. So what I mean by keeping it fractions is like put those, so that's what I did. Then my 5 NCR2 to get 10. And I'm just like, okay, multiply that by, but leave your 1/3 in parentheses and square it. And the 2/3 in parentheses and square it. If you put like 0.33 or 0.66, your answer is going to be kind of different from that. Questions on number 6 here? Am I going too fast or moving? When you're done with 6, then have it. Alright, so 7, just be really careful with the wording, because this is where a lot of people start screwing them up. It's like 2 words that change everything in this. So I've still got a 6-question true-false test. Not still. You got a 6-question true-false test. Some people will do this. Like, okay, n equals 6. B equals 0.5 because it's true-false. Q equals 0.5. And then they'll write x equals 5. This one, I'm saying at least 5. So, like, what helps me is to write out the possibilities. Like, there's 6 questions. I could get 0, 1, 2, 3, 4, 5, or 6 correct. Well, at least 5 is both of those. So, when you go to write your x, add. So what you got to do is just rub twice. So do it once with the 5, once with 6, and then add them up. Sorry, so exhausting. So I got this 0.09375 here. And then 0.0156. That's 0.109. Agree? You there yet? So disagree. You got it. So if you got that, try 8. If you got a question on 7, let me know. Make sure in 8 you see this key phrase here, no more than 1. That adds to your work a little bit. So let's walk around some good questions. Yeah. Conversation. No more than 1, again, it helps me to write out like the possibilities, and no more than 1 means it could get 0 or 1. Neither of those are more than 1. So I gotta do the problem twice. Make sure you know P is 0.2, right? It's like 1/5. There's 5 options to choose from. So I got 0.8192. Okay, there you go. Sorry if I slowed down for you. Did not work, please answer. If you have questions, please ask. questions here? Are we good to move on, or are people still working on everything? Thumbs up if you're ready to move forward.
Yes, so why are they both the same? Both probably negative 0 and negative 1 are both the same. Or is that? Or why is that?
They are.
Yeah.
Yeah.
Which is really weird. I thought we can't. There's a lot of ways to get.
So like this is just doubled. This is just
Yeah.
half
Yeah.
both times. So this is 1. So this is just 0.8 to the 4. It's just a coincidence. I'm trying to figure out like why it's a coincidence. So then this is 0.8 to the 3rd. Okay, so this is 4. What's 4 times 0.2? 0.8. And then so now there's 4.8s. So it's just like random. It's not like gonna happen again. I mean, it might happen again. There's no real reason. Okay, other questions? All right, I want to look at that like rectangle thing again and show you what why I put it up there. So you don't have to write this down. Like you're not responsible for this. I just think it's interesting. It has to do with what we're talking about. So let's say I'm starting here and I'm ending here. So I'm making that big 10 by 10 grid like a much smaller scenario, so it's easier to look at. And I wanted to go from here to here. How many different routes are there to go from here to here? What are the two?
Well, you can go all the way up and all the way over. And all the way
You can't go down and you can't go back.
Oh, we're still talking about that.
Yeah.
There's only one.
So there's just one. What if I said go from here to here? What are the two?
One way. Oh, right.
There's like 2 steps, but there's only one. Like if I said go from there to there, you have to go that one way. What about here? One, right? Same thing on the side. Do you agree? So there's one. There's only one way. There's only one way. What about that corner? So I can go up and over, or I can go over and up. So that's 2. Don't say it out loud because I want everyone to think about it, but that corner. From the start to that corner, how many different paths are there? 3? Agree? So you can go like up and then over and then up, or you can do like this zigzag thing. This corner, how many paths? It would be 3. Kind of the same thing, just like flips. So I can go like up and over and up, or I can go up, over and up. Don't say it, but think about that one. So I go over right away and then up. Up 1 and then over and up. Go 2 and then over and up. Right, up 3 and then over. So there's 4. So this would have to be 4 also, right? Like the same thing, just sideways. Don't say it yet. Try that one. Really gotta work on the not saying it. I heard it from here. You said the number and then you said like the thing. Do you not realize that you're talking? Like I can play the video back if you want. This one's a little trickier to count. Think, I don't know. I go all the way up and then over. I go up 1 and then over, and then up to get there. I can go up 1, over, and then zigzag my way to get there. So there's 3 paths I can do, like if I start going up. 1, 2, 3. And then you'd have 3 paths if you start going to the right too. So 1, 2, 3. So there's 6 ways to get to that corner. I don't know if you guys see what's happening yet. Don't say it. What? Oh, it looks like a towel. That's why. Thank you. So if I were to ask you this one, you could count them, but it gets kind of hard at that point to keep track. It's 10. This one's 10. What's that one going to be? How did I get that 10? I didn't count them. 4 plus 6. If there's 4 paths to get to here, and there's 6 less paths to get to here, there's 10 to get to there. Same thing there. So then if there's 10 paths to get to here, and 10 paths to get to here, there's 20 to get to there. Well, what am I making? That's Pascal's triangle. Right? So that's your 1, 1, 1, 2, 1, 1, 3, 3, 1. Isn't that cool?
That's cool.
So, at the end of it, like if you wanted to get the actual answer, there's 20 like little line segments and there's 10 different, it's 20 choose 10. So this is like, this number is, this is 4 choose 2. This is 2 choose 1. This is 6 choose 3. So if you like carry that forward, you end up doing 20 choose 10. And it's like 184,000 or something. So anyway, like you're not responsible for that, but I think it's a cool like, problem with Pascal's triangle as well. Questions for me now? Okay, so we'll keep going tomorrow. You don't have to do any notes for tomorrow. We'll just keep going with